Thank you. We're looking at hyperbolas now. I've asked you to plot these graphs. Now, because you haven't seen a lot of hyperbolas or any new graph, I'm going to ask you guys to plot them. What does plotting mean? Yeah, so finding coordinates. So what you're probably going to do is look at some sort of a table where you've got x and y. Okay, so when x is 1, 1 times 6 is 6. When x is 2, y is 3. So what I should be doing over here is putting up here, plotting 1, 6, 2, 3. When x is 3, y is 2. When x is, what I put, 4? 5, 6. Stick with those nice round numbers. Okay. In other words, you're sticking to factors. Okay. Any questions of that one? Is that my graph? No. Yeah, because -1 times -6 is 6. So it should be there. -2 times -3, -3 times -2, and -6 times -1. So there's my graph. Yeah, always have two parts to it. So, you know what I mean? Hyperbolas, which are called rectangular hyperbolas, are going to have two parts to them. Okay? What do you notice about the two parts? They are in opposite corners, probably. They're symmetrical, but they're in opposite corners. Okay? Any other questions about that? So what are the features so far of that graph? What are some features of that graph? How do you not never touch the intercept? You haven't identified that. Yep. So feature number 1, which is really important, there is going to be an asymptote for your x and the y. Okay, there's going to be two asymptotes. In this particular occasion, those two asymptotes happen to be along the x-axis and the y-axis. Okay, so there are my asymptotes. Okay, from this point here, on this asymptote, it's across 1 up 6, across 2 up 3, across 3 up 2. From that point there. Okay, that is the most important point of rectangular hyperbola. Going back to parabolas, what was the most important point of a parabola? The vertex. So what's going to move? What's going to move when we try and move these hyperbolas? Yeah, where those asymptotes meet. Okay, if we can find where those asymptotes meet, then drawing a hyperbola is just as easy as saying what are the two factors of 6 and then going 1 and 6, 2 and 3, 3 and 2, 6 and 1, -1, and just sketching it like that. Okay. Any other key points? Asymptote. Do you know what asymptote means? Never touches, or goes away from it. Have you guys seen an asymptote before? A graph with an asymptote before? Exponential graphs. Yeah, your exponential graphs have asymptotes. All right. So, looking at xy equals 12 now. Xy equals 12. What are we looking for? Factors of 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. 4 and 3, 6 and 2, 12 and 1. But this is a negative. Okay, so I'm just going to have -1 and 12, -2 and 6, -3 and 4, -4 and 3, -6 and 2, and there's my parabola there. Happy? Is that it? No, make sure to the other side. 2, 6. Hopefully that is that. Yeah, like that. Hey, is that my graph? What else do I need to draw? What else do I need to draw? Yeah, make sure you draw the asymptotes, alright? So, draw those dotted lines. I'm not sure why I chose a massive fat highlighter there, but it's a bit of a mess. I don't know. Why do you have to do that? Because your graph will never touch those points. And it's really important that they do not touch those points. Yeah. Any questions? Right, I'm just going to pause the video there. Okay. So remember, y equals 6x. That function there is hyperbola. Sorry, that's not hyperbola. Let's minimize that. Y equals x over 6 over x, sorry, that is a hyperbola. So that one there, how do I translate that? How is that one there being shifted, do you think? Looking at this blue one now. To the right 2 and 4 down. Can you see that? It's exactly the same as the parabola zone. Isn't it? Right next to the x, so that's going to shift to the right 2, because at the end it's going to go down 4. So what's going to shift? Yeah, the asymptotes. Okay, so the asymptotes shift to the right 2. The asymptote shifts down 4. Okay, can everyone see those now? How am I going to draw this graph now? Pardon? Yeah, use the asymptotes as you were sort of just doing before, eh? And so now you're just looking for 2 numbers that multiply to 6. 2 and 3. So from here, across 2 up 3. From here, from this point here, across 3 up 2. 6 and 1, across 6 up 1. Any others? 1 and 6 up 1, across 1 up 6. That's 6. Any other parts? Other side. You make sure you have your 2 sides. So across 2 down 3, across 3 down 2, 1 and 6. Okay, so there's my graph. Obviously not the dot in the middle, but there is my hyperbola. So do the hyperbolas touch the x-axis and the y-axis? They have, haven't they? Yes. So that's just the asymptotes, okay? So make sure you are aware of that. Hyperbolas can touch the x and y-axis, but it would have some sort of translation around it. Okay? Any questions with that stuff? Alright, what we'll do is we will